Welcome to another episode of Azure video series from K21Academy. In this video, we will be covering virtual networks and subnet, public, private, static and dynamic IP, route table and route rules, network security group, security rules for egress and ingress, service endpoints, application security group, Azure Firewall, along with Azure Firewall Manager, Bastion Host, NAT Gateway, Azure DNS, Azure Load Balancer, Application Gateway, Azure Traffic Manager, Express Route, VPN Gateway, Local Network Gateway, Virtual WAN, VNet Peering, Hub and Spoke Model, and Gateway Transit. In the end, we will also share details about our step-by-step Azure Cloud Training program, which will not only help you understand basics, but it will also give you real-life hands-on experience. It would be helpful, especially when you're preparing for Microsoft Azure certifications like Certified Azure Administrator Associate and Certified Azure Solution Architect Expert. For the certification exams, you should have an understanding of Azure networks. Now, let's hear from a cloud expert on the same.
In this module, we will be learning virtual networking. Here we will start with learning virtual networks and how can we segregate virtual networks into multiple subnets. If you take Azure, there are n number of networking components starting from the NIC card of the virtual machine and then how we segregate the network into multiple VNets and subnets and how can I balance my load and the multiple gateways of both application and virtual network gateway. We also have local network gateway and many other networking components are there. But before even we go there, it's really very important to understand how networking works. What is networking? How IP addressing works? What is CIDR notation? So we are going to use the whiteboard to explain some of the basics. Like how we have multiple mobile numbers to contact each other, networking has something called IP address, and we have IP version 4 and IP version 6. IP version 4 is usually an 8-bit, 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 8-bit. So this is an 8-bit, 888. So overall, it's a 32-bit IP addressing, wherein in IPv6, it's 128-bit alphanumeric code. It's very long. Currently, telecom industry is leveraging IPv6 heavily. If you take IPv4, I can do subnetting and supernetting to classify into multiple small pieces of network. And we have 5 different classes of IP address from A to E. A is 0 to 126 and B is 128 to 191 and 192 to 223, 224 to 239, 240 to 255. Overall from 0 to 255, so it's 256 overall. Do we have anything which is missing? Yes, we have 127 which is missing, which is also called a loopback IP address. It is also called home. If I want to check the internet connection of my laptop and if I really want to start with my own network card, then I can ping 127.0.0.1. And if I get a ping reply, which means that it doesn't have any issues with my laptop, especially with my network card. Let me try it in my laptop. I don't have any issues with the internet, so it should ping. I'm getting the ping for my loopback IP address. Let's see, I'm taking one particular bit. It starts from 0 to 255, and the second bit also goes from 0 to 255. So the IP addressing starts from 00002, 255, 255, 255, 255. So we have millions of IP address, and how are we going to classify which one to use and which one to reserve? For this, we need to understand CIDR notation, classless inter-domain routing. If I pick up one IP address like this /16, which means 8 plus 8. I am blocking the first 16 bits for network, and the remaining 0 to 255 and 0 to 255 are for my host. If I need a big network, then I need to choose maximum bits from here. And if I need a small network but more host, which means I do have only limited departments, but the employees within the department is more. So your department is nothing but your network. The employees are nothing but the host IP. So if I write in 10.1.10/24, which means I am blocking the first 3 octet. So all I get is 256 IP address, which is 0 to 255 of the last bit. If I have multiple departments but only very less employees in the department, then I can go for it. We also have two broad classification of IPv4, that is your public and your private IP. Public is mainly for management traffic. If you have a virtual machine, quickly go to the overview page and check. You have two IP address. One is public, another one is private. So public, we have just given the name, for example, VM-PIP or so and so. But Microsoft gets the list of public IPs from IANA, Internet Assigned Numbers Authority. That is why even if we have shut down our server, we still have to pay for operating system disk and resources like public IP. Because Microsoft has paid it to IANA, we also have to pay few cents to Microsoft. Every public IP, or I would say most of the public IPs, are associated with an website. But it's not the case with private. We do have limited range of private IPs. Let me write it here. These are the three range of private IPs, the 10 series and the sum of the IP address in the 172.16 series and also the complete 192.168 series. Why is it called private? Because the data traffic happens via private IP address while public IP address is mainly for management. Do you remember we used to take remote session to our virtual machine via the public IP, not via the private IP? If two virtual machines communicate with each other, then it is always via private IP. I can have the same IP address and subnetting in my subscription, and you can also use the same thing. For example, I have picked up 10.1.0.0 as one of my IP address. Well, you can use it under your subscription because it's private. This IP address is completely private for my subscription. Within my subscription, I cannot use it again, but from your subscription, you can use it. Now, let's see, we will quickly create a new boundary. So far, we have always created only the logical boundary, which is my resource group. Let's say this is the resource group which is called network, and in between the network we have directly created a virtual machine, and under the third page of creating virtual machine we have kept everything as default option. But today we are not going to do the same thing. We are going to create a network boundary also. This is our logical boundary, and within that we are also going to create our network boundary, and then we will place the virtual machine or any other products that you need. So this is the network boundary. It is called VNet. And what could be my IP addressing range? You cannot give single IP address. You need to give the IP address range. I'm going to choose 10.1.0.0/16, which means I'm blocking the first two for network and the remaining two for host. Now, within this VNet, if you see the overall IP address that I get in this range, it's vast. It is 65,536. Now that becomes tough for me to manage and also apply security rules. And there is one thumb rule. Everybody within the VNet can talk to each other. It is one network boundary. Let's say I have a virtual machine, I have a SQL database, I also have a Cosmos DB. All of these resources can talk to each other within my network. In that case, if I place all my machines within the network, how will I apply security rules? Now for this, I am allowed to again segregate my network into multiple small pieces, which is nothing but my subnet. I'm going to name it as S1 and S2. And my S1 can be 10, 1 because I cannot change the first two octets. It is reserved already on the VNet level. This is my VNet. It's already fixed. So what is the next one available? The third octet. Now here I can start from 0 or 1. Here I'm starting from 1. 24. Why? Because the third one, I'm reserving the third one, which is the 1 series. And S2 can be 10, 1, 2, 0/24. Similarly, I can create n number of subnets. So within this, if you see, I get only 256 IP address. Now, this is how we segregate our networks. The first one is the logical boundary, and the second one is our network boundary. And also for the security boundary, we have the the subnet. In Azure, there is an exception. You cannot use the IP address 0, 1, 2, 3, and 255. If you have created your virtual machine, probably you might have paid attention or may not. But if you have a virtual machine, quickly go and check. If you have chosen the IP address, your first available IP address will be always 4 because 0 is the network ID and these three are reserved for Azure for future purpose, mainly for gateways. And 255 is the broadcast ID. Now keep in mind that you cannot use 1, 2, and 3. And private IP is by default assigned by Azure. All we have to do is give the network boundary with the IP range, and the rest and IP addressing assignment is usually taken care by Azure. Now with this, can we quickly go ahead and create our network along with the subnet? Once again, I'm going to write the same thing. This is the VNet wherein 10.1.0.0/16. Well, you can also try. I'm going to create with one subnet, which is 10.1.1.0/24. Without a subnet, you cannot create VNet. But once the entire network boundary is chosen, then you can add n number of subnets. The second subnet is going to be 10.1.2.0/24. You might ask, is there any limitation for the VNet in the subscription level? Yes, there is called soft limit and there is also called hard limit. Soft limit is 50 VNets per subscription and hard limit is 500. Why is there a difference? So that Microsoft can keep a track of the usage. Once your soft limit is over, call Microsoft and there is no charge for it. They will move from 50 to 500. They will enable the hard limit for you. You can use the same numbering also. Now let's go back to the portal and try the same thing. I already have a resource group called networking. You can type in virtual network on top, or you can also choose from the left hand side. I'll add a virtual network. I'll use the same resource group and I'm going to name it as VNet 1. I'll create it in West US. The next is IP address, and by default Azure gives the IP address. You are free to change it. Here we are going to use the 10.1 series, and the subnet, without one subnet we cannot add the VNet. And the subnet is 10.1, which is already fixed for VNet 10/24. On the VNet level, we have two different levels of security, DDoS and firewall, which we have already covered in AZ900. But once the VNet creation is done, we will go back to the whiteboard and once again understand what is DDoS and what is firewall. I'm not going to choose the tag. Let me go ahead and create our first network boundary. While the creation is going on, we will try to understand the security part of it. So here is our VNet. You might ask, why do I have to talk about security? It's cloud. It's supposed to be a silver bullet, isn't it? It's not. Security is a shared responsibility. Any cloud vendor you go to, the cloud vendor will take care of certain things and you have to take care of certain things. For example, the data that you put in cloud, it's always a customer's responsibility to give the identity and access management to the right set of people. Similarly, on the VNet level, I'm going to call it as perimeter security. And I have two levels of security here, which is my DDoS, which is the distributed denial of service. By default, DDoS basic is enabled. You can also upgrade it to the standard one. And you also have firewall, Azure Firewall, which is nothing but a firewall as a service. Please go to Azure pricing calculator, choose Azure Firewall as the product and choose your target region and check how much is the pricing for firewall. Azure Firewall is one of the very few expensive resources within Azure. Have you ever wondered why you are able to access everything in your office but not Facebook? Or I'm not able to access anything but only BBC and CNN? It's all because firewall. It's nothing but your access control list wherein you can allow and deny some of the IP addresses or the website. It can be 1111 or it can also be wildcard entry. The star is called wildcard entry dot facebook.com, which means photos.facebook.com, videos.facebook.com, sales.facebook.com, anything.facebook.com. Since VNet is always on the IP address level, firewall has to be on the VNet. These are the two different levels of security that we have on the VNet level. Now let's go back to our portal. Our VNet is ready. If you click on the subnet, we have our first subnet. Can we create one more subnet? So I'm going to call it as S2 and call it as 10 to 24 series. We'll keep all the other options as basic because we haven't learned about network security group, routing table, and service endpoint.
Hey there, so that was our Azure administration trainer talking about the virtual network, IP address spacing, and CIDR, which is classless inter-domain routing. That is the one which you'll be using quite extensively at different places. So just to do a quick recap on what we covered. So you have a virtual network, that's outer line. We already saw that. And then within this virtual network, you create something called as subnet. And within a subnet, then you create, or when you create a subnet, that is where, or when you create a virtual network, you get a bigger IP range or IP group or continuous block of IP addresses. You break that bigger network into smaller networks we call subnet, and any machine that you create, like whether a Windows or Linux machine or a load balancer or any gateway, any device that needs a IP address, that IP address will be picked up from this subnet IP address. So that's what is that subnet and IPs will belong. Now, in this subnet, you're going to create, for example, machines. Machines will have something called as network interface cards or an Ethernet card or in a virtual way through which one machine can talk to another machine. And additionally, on those virtual machines, you can assign IPs. We'll show them as well. Then this network can then either talk to other network. Later in this, we're going to see how they talk or how do you connect these two networks separately. Also later in this module, we're also going to talk about how can you connect your network on the cloud, which is VNet, virtual network, with on-premise. So that's network. Now, when you create a network, you will go and can create subnets, and you can create, depending on how bigger the virtual network was, and that bigger or size will be dictated by the CIDR range you select when you create a virtual network. And all those things were explained earlier in the previous lesson. So if you missed that, or if you want to recap one more time, have a look at that previous lesson one more time. Then similarly, then you will be creating subnets inside that. And this is an example of subnet being created. And then what you can do is you can create IP addresses. Those IP addresses can be public or private. Now, public IP addresses are one which you can access from the internet, or you can go out from these public IP addresses to the out as well. Now, whereas private IP addresses are IP addresses which can be only visible, or you can connect only from within that network. You can't connect from outside. So if I'm on internet and I want to connect to that machine which is have a private IP, I can't do that unless I have some other things which are like load balancer, which we'll see in later. But directly I can't reach out from internet to this private IP. I can only do public IP. Now, other thing is that these IPs can be dynamic or static. Dynamic IP is every time that IP might change as well. Whereas static IPs are IPs will stay always remain same. The dynamic IPs which Azure provide, you can assign a machine a dynamic IP, meaning next time a machine restart, the IP address might change. Whereas in static IP, the IP address will always stay same when you assign. So let me quickly show it to you on Azure account, and how do you create these IP addresses or NIC or network interface cards or VNet or subnets. So this is I'm on Azure portal. You should already have created an account in Azure portal. If you're not, there is a previous module or separate module about how do you create an account in Azure, and then portal walkthrough about. Just quickly, this is like basically white background and left hand side is all, this is the navigation, easy navigation menu bar. Now, if you might looked into the previous lesson, the instructor was showing you black screen, and that configuration you can change by going to this gear box here. You click on this and you can say, first of all, do you want to sign out? And I've set in my settings never to sign out when inactive. So, but depending on where exactly you're accessing, you might say sign out, or after 15, 20, 30 minutes as well, when to sign out. Then our inactivity time. You can also see the default view homepage or dashboard, or like, do you want to see fly out, which means left hand side is gone or docked, and what kind of a theme you want black or white theme. So if you see now, it's all black theme, or I want this theme, or I want prefer this theme, depending on. Also high contrast, do you want contrast, none, or white or black contrast? So depending on that, you can see. And do you want to enable pop-up notification? Any notification comes as a pop-up or not? So that's just quick change on the screen. Now here you will go and create VNet. I'm not going to create VNet. You saw in one of the previous lessons on VNet. One of the VNet is already right now here. Now this VNet will have subnets. So if you go inside that VNet, you will see the list of subnets. So if you see under this VNet, we have one subnet which is default subnet. The IP address is 10.0.0.0 side space 24, which means you will have 2 to the power 8, like 32 IPs minus, it will be always 32 because you have 8 bits, 8 bits, 8 bits, 8 bits, 32. So 32 minus 24, 8. 2 to the power 8, which is I think around 256 IPs, and some IPs, few starting IPs and end IPs are blocked or reserved for communication internally by Azure. So you have around 250 IPs available on this machine here for you, roughly. So that's my subnet. Now, if you want to look at the NIC, so or network interface card, so you'll click on network interface NIC, and right now I have a network interface card called Docker. I can already delete if I want, so I'll click on this, and if I want to delete, I can go and delete it here and say yes, delete. I can go and create, maybe it's being used by something else, so I'll say network interface cards and then click on add here, and I can go and add network interface cards here, and then I can attach these network interface cards with a machine. So I'll give a name, I'll give a resource group. Now again, a resource group is nothing but collection of resources, which resource in this case is about my IP address, that's resource. I'll give a name, or I'll select a virtual network through which the IP will be assigned to this NIC card, and then I can attach this network interface card to a machine later. So that's NIC, and if I need to look at the IPs, you simply select on IP, and this is your public IP. So you see what all public IP address you can create and assign the public IP addresses here. So go here and assign the public IPs from here. Now, this is us talking about here. Do you want public IP to be IPv4 version or IPv6? This is the versioning. IPv6 is not every application support IPv6, but you can Google out on IPv4 and 6 as well. So that's IP address. Again, I can assign these IP addresses to my virtual machines later. So that's my IP address here. So that's in a nutshell about my public IP, subnets, and virtual network. In this lesson, we are going to look at what is a route table. So as a name suggests, this is for routing the network or your data or traffic from one network to another network. Now, if you see there is a network, these outer dotted line here represents one network, which is VNet 1, and this is another network called VNet 2. Now, machines within a network can talk to each other without any routing table. That's an internal within VNet, the machines can talk to each other. But if a machine in one network or one VNet needs to go out to other places like storage account, or you have this network which needs to talk to your application in on-premise, which is your customer data center, or this network, a machine in this network needs to talk to another network. This is where you will be needing route tables, where you create a route table. Now, when I say a machine in one network needs to talk to another network, they need a route table. That's one method of connecting. Other method is VNet peering, which we'll cover in later modules. So in a nutshell, route table will dictate or help in connections going out of the virtual or from a network, which could be other services, or it could be other networks, or it could be your on-premise data center. Now let's quickly go and see how do you create a routing rule. Or before I go further and explain you what is this here. So we can say there is a user-defined route, and that might say that all these IPs, or maybe 10.0.0.16, you want to take this to some other network. So you will add a route rule and say, if anyone try to access from this network 10.0.0.0 something 16, take it to this way. So that is what that route table will use. Similarly, let's suppose this is a network we are already on 10.0, and if we create another route rule which says that any IPs from 192 range or any IPs from this range, take it to my connected through VPN gateway to on-premise, then that's how it will know that, hey, routing, I need to go to this particular on-premise via the VPN gateway. So all those things you'll define in route table. So let me quickly go and show it to you on the Azure portal. How do you create a route table? So this is where I'm back on Azure portal. You type a route tables and you see a route table here. So by default, there is nothing. So you click on either create a route table or click on add a route table here. You specify your subscription. So you select your subscription. In my case, it's Microsoft Partner Network. You might be having a trial version. And then you specify the resource group, which I said is collection of resources. I can use one of the existing one which I created in past. If you're doing it first time, you will not have any resource group. So you'll create a resource group. Maybe say I'll use this in future as well. So I'll say network or K21 network or network underscore K21 or network K21. That's how I know that it's for my networking I'm using. Then you specify the name of that route table. So I'll say route table 1. In which region this route table exists, and propagate gateway routes. That is basically, let's suppose you configure or you connect this routing table with another network, or you, like for example, on-premise or VPN gateway. So the whatever is the routes mentioned in the gateway, that you have to either manually add all those rules. But if you select this option here, it will automatically propagate those gateway rules here as well. Again, gateway routes. Again, this is a little bit more advanced networking topic on propagating that gateway rules. But depending on which training you're attending, you can ask your appropriate trainer in the networking module when we go deeper into these topics. You click on create a route table. Now you've just created an outer shell. You've not written any route rules here. So once you've reviewed, click on create. and it will take few seconds to create this, and you will see a notification here saying that routing table deployment in progress, and it'll say that deployment succeeded successfully. So you refresh here, and then once it's done, it will say deployment is complete. You go to the resource, or you can go back again, search here and say route table again, and you will now see the route table being created here. So let me see, it should be, now we have deployment succeeded. Sorry, it was came a little bit later. So I'll refresh here. Yeah, so we see a route table here now. Click on this route table, and now we need to write the rules or routing rules which are saying. So click on route table, and this is where you say routes. Click on routes, and then click on add. And this is where I'll say that, for example, to on-premise or to customer data center, and then address prefix, which means what IP address range is. So I'll say 192.168.0.0/16, which means all the IPs within this range, you take them to where exactly virtual network gateway. So now, what is virtual network gateway? We'll cover when we do VPN gateway. That's what is virtual network gateway. So I'll point it to say any range IPs coming from to any IPs. If my machine in this network on which I'm going to attach, I'll show that as well. So this route table needs to be associated to a network or to a subnet, so or to a machine. We'll see that as well in a minute. So that machine or that network will, any machines in that network needs to go to this IP address. That connection will take to the virtual network gateway, and then gateway will have the definition for further forward and where exactly you're doing, which is on premise. That's how the connection will be. Click on OK. Now you've added a route, and then you can say on which subnet this routing table is associated. So you select subnet and click on associate, and then pick up one of the network. So in this case, I've not created any network. Otherwise, it would have been visible here and say virtual network, and then you add here. So let me quickly, or you can do it. I'm not going to show it to here because we want to keep it short and quick. So this is where you will select network, and that means these subnets will be attached on here for you. So in that case, any subnet that has this route attached, it'll use that routing way to go out to the destination, which is your on-premise server. So that's about a route table. So let's look in this lesson what is a network security group. So network security group is, think of it as a firewall at a network level, which is provided inbuilt by Azure network. So network security group is used to filter out the network traffic going out or coming in. So coming in to or going out from Azure network, which could be or any resources like virtual machine or load balancer and other places, other things. So network security group contains security rules going out, which is like egress, and coming in, which is ingress. Rules to allow or deny any inbound traffic going out or coming back in as well. So what you do is, it's quite simple and straightforward. You go and create a network security group, and in that security group, you write rules like what is allowed, what is denied. So, and then you attach that network security group to either a virtual machine or to a network as well. So that's what is about network security group. Now let's look into the portal and see how to create a network security group and attach it or add some rules into this. So I'm into the portal again. Just search for network security group. So this is the third number here. Click on network security group. And by default, I'm using some Docker, so we'll leave it default. You click on, you may not see that on your portal. Click on add, and then always you will be selecting your subscription. By default, you might have a trial account, or depending on kind of a subscription. In my case, we are Microsoft partner, so we see Microsoft partner network. You select a resource group. Now, as I said, we created a resource group earlier, but if you don't have any resource group, click and say create a new. Resource group is collection of resources, like network security group is one resource. My IPs are another resource. Network is another resource. So I'll click here and say I created this network K21 already, the resource group, and then we'll give name of the network security group. So we'll say NSG1 and K21. And then if you want, you can add metadata like is it for production, is it for dev, test, or what department. We simply say review and create. Now, once you've verified all the details are correct, you click on, or maybe, okay, so maybe my network problem at my end. And on review and create button, you click on create and it will go and create. Just give it a minute or so. And then you will go to the network security group. So you can search again NSG and click on that, refresh the screen here, and you should get a notification saying that deployment is successful. And sometime you have to refresh few times. So wait for a minute or so and then come back here and refresh the screen. So if you see now, I got the network security group. You go to this network security group, and this is where you will be adding some rules here. So if you see by default, you see these rules here, outbound rule and inbound rule. So you can click on inbound and you can add any more inbound rules, or similarly outbound, you can see allow or deny outbound rules. Now, once you have these rules, you need to associate this with a subnet or a network interface card. So these network security group, in order to use them, you need to be associating them with a subnet. So you click on associate and then you select a network. I already created a network called VNet, and inside that I created a default subnet, which is subnet. You attach and say okay. So now this subnet will start using this particular security group. You can also attach this network security group to a specific network interface cards as well. And if you have created a network interface card, you will get a you can attach it. I have not created a network interface card, NIC, otherwise you can create. We looked at NIC in one of the previous lessons. So that is about firewall or your network security group. So network security group is a kind of a firewall at a network level, which will filter traffic going out or coming back in, and you can write these rules. Ingress incoming, egress outgoing. In this lesson, we are going to look at another component of network, which is service endpoint. Now, what service endpoint help you is these service endpoints are attached or accessible from virtual network that helps you to filter egress network traffic to a particular Azure service. That Azure service could be a Azure storage account, or it could be a Azure database. It could be various other services that are available that needs to be accessed from a virtual machine. And now they basically provide a much granular access to or granular way to control what you can access or how that access happens securely over the network. So the best way to do or show it to you is you create a service endpoint, and then you go inside a network, and then you create a service endpoint and pointing to any of these services. So you can point it to a Azure Active Directory or Cosmos DB or Cognitive Services or Registry, which is a image registry, any of these services. Now, any resource then in the network can use this service endpoint or through that service endpoint to that particular service, rather than going maybe directly to you enter a specific details about that, you use that service endpoint. So just to show you how it's being created, I'm in my portal. So I'm going to first go and create go to the network or VNet virtual network. And I'm in virtual network here. This is the network which I've already created. So go to this network, and then below that there'll be a service endpoint. So you click on service endpoint, and then you add a service endpoint here. Select the service and then click on add. That's how the service endpoint will be created. So just to recap, service endpoint allows you to filter egress outgoing traffic to a particular service, in this case Azure storage account, or to here in this case SQL database. And in this lesson, we are going to look at application security group. So the application security group, as per the diagram, as shown in the diagram, helps you to manage security of your virtual machines by grouping them according to the applications that run on top of that virtual machines. So for example, you have a couple of virtual machines that act as a web server, then another set of services acting as an application server, and third couple of sets of other services or servers on which your database is running. Now, as you know, in a practical world, the database server should only allow connections from the application server, not from the internet users directly, nor they should be able to connect from web servers. Similarly, the application server should only be able to connect from the web server, not from the internet. And web servers should only allow or should be allowed, or internet users should be allowed connections only on the web servers. Now, what one method is, as we saw in network security group, what you can do is you can create some rules and assign them manually to web servers here, and then similarly app servers, and say allow connections from specific to these IP addresses and or web server IPs addresses or virtual machine IP addresses. And then in future you add more virtual machines, you add more IPs allow on app servers here. And that becomes a little bit more challenging. Technically you can do it, but it becomes more tiring and cumbersome process. So instead of that, what you can do is you can create a application security group and say, and then go to the virtual machine and say these set of servers or these virtual machines are part of this application group, server group. Similarly, these set of machines are part of this application server group. And then later you can use these application service groups into the network security group rules to allow or source port or source range. So what you're going to do is then you say app servers allow connections on port, whatever app server port number, for example 8080, but only from a application server group, or sorry, application security group as web server. So that way now you don't need to specify the source IPs of these web servers in firewall rule here. Let me explain you what I mean by that. So first is you're going to create a security group. So you will go to the application security group and create that security group. And then you are going to go to the virtual machine and then assign that particular security group. So let's suppose this virtual machine is for web server. We'll create a application security group. I've already created an application security group called K21Academy and then assign this to this machine. Then later, I'm going to this security, then I'm going to my network security group that we covered earlier, which is nothing but firewall, which will have ingress and egress rule. So I'll go in the network security group. In one of the ingress rule, which is inbound security rule, I'll say add a rule, but this time I'm saying source is my application security group, and whatever the security group which I've assigned, maybe web server or a DB server or app server and so on. So that's how I'll be using this network application security group. So in a nutshell, application security group helps you to manage your security of virtual machines by putting them into a group of applications or similar set of applications that run. And these application security group then can be later used inside the network security group, which is a firewall, to say allow or deny. And in this lesson, we are going to talk about Azure Firewall and Azure Firewall Manager. So Azure Firewall is a managed and cloud or fully managed cloud-based network security service that protects all your Azure network resources. So it's typical to what you used to do in on-premise. You used to have a firewall for any of users or like any access that used to come to the network that used to go via the firewall. On the similar way, you have a managed firewall that you can, or a firewall that you can create and build on Azure and set it in front of your network or with your network, so that any connections that comes to that network will go through the firewall. And that firewall basically has a pre-built or inbuilt high availability, and it can scale up as the request comes, meaning that it's highly scalable. It means it can protect any kind of a user access that comes. It has the policies to protect both layer 3 and layer 7 of OSI model. Also, it uses the threat intelligence from different sources to find out, or if any request is coming from a malicious IP, it will automatically detect those malicious IPs and protect connections as well. So that's what is Azure Firewall. So let's first quickly show and see where do you find or how do you create Azure Firewall and attach. But before that, let me also cover Azure Firewall Manager. This Azure Firewall Manager is a recently added. When I say recently, I mean in late 2020, early 2021. This firewall is a security management service that provides central security policy and route management for your for cloud-based security parameter. So you can manage all your security policies as well as routing management for your firewalls. There are two type of architecture deployment you can do for firewall. One is called a secure virtual hub. Now, what is virtual hub? We are going to cover in future lessons. And then second is hub virtual network. So these are the two architecture style of doing in Azure Firewall Manager. Now, if you're part of AZ 303, 304, which is Azure Solution Architect, this Azure Firewall Manager is a recently added topic in Azure Solution Architect, and that's in that program we're going to cover that a little bit in detail about Azure Firewall Manager and its implementation. Now, the hub virtual network implementation, there is a hub and spoke model. Again, we are going to look at when you have multiple virtual networks, you can connect them with each other and can configure them in a hub and spoke model. What is hub and spoke model? We'll see in one of the subsequent lessons. Or you can also deploy, as I said earlier, in a virtual hub model. So what is a virtual WAN hub? Wide area network, we'll see that as well. So you can deploy this Azure Firewall in any of these two implementations. So now let's go and quickly on Azure console and see what is Azure Firewall or how to create Azure Firewall. So if you notice, I'm in my Microsoft Azure portal. So here you need to do is you need to search for firewall. So you click on firewalls and then you will say create a firewall. And this is where you provide your resource group. We're creating name of the firewall. And then there are different tiers like premium service. There are extra, this is the preview phase feature right now, but there are two firewall tiers. The premium is more expensive. Then there are other parameters and policies and other parameters or things that you're going to specify. And then you're going to say, this firewall will be used with a new virtual network or you're going to create it with existing network. Now, this is because this is a network overview. So I'm going to keep it high level, but this is just to show you this is where you come and see the firewall. Or you can go to virtual network. Let's suppose this is, I have not virtual machines, but VNet. So these are my virtual networks. And then I've already a demo VNet K21. And in that, I'll be able to say here under firewall, you'll see what firewall is attached. So right now there is no firewall. You can click and add a new firewall. So that firewall, similarly, you can go and look at firewall manager. So you click on firewall manager, and this is where you will see the two deployment method. I said you can go for either virtual network or virtual hub. And if you go for virtual network, it will list down all the virtual networks available. Virtual hub, we have not created any virtual hub. Right now you don't have, that's why you don't have any virtual hub here. So that's about firewall and firewall manager. In this lesson, we are going to look at Bastion Host, or also called as jump box, or also like a remote server host. Now, the purpose of this is for you, as name suggests, is a Bastion, which is for your clients coming from over the internet. So let's suppose this is your, you have a virtual network that we saw earlier. In that virtual network, you create multiple machines of type Windows and Linux. Now, one way to connect to these machines over the internet is you open if it's a Windows machine, you open port number 3389 RDP port. Or if it's a Linux machine, you open port 22. So the RDP is a remote desktop protocol, which is or listening on port number 3389, or SSH, that stands for secure shell. It's listening on port number 22. Now both are these days are in the data for connection from Windows connection to for a machine running on Windows or machine running on SS or Linux machines on port number 22. So instead of doing that, because there could be some security loopholes on these two protocols, or there might be some compromise risk on these. So what you can do, or what Microsoft Azure has introduced, is a Bastion host or a server which is accepting connections over the internet, but on SSL protocol 443, which is a HTTPS protocol. So instead of opening the port number 3389 or port number 22 to the internet or for your on-premise, you first connect to a Bastion host on port number 443, which is HTTPS. You'll be going browser. The user doesn't need any SSH client, or the user doesn't need any RDP client. They will go to the browser, type HTTPS, and then the Bastion host name, and then they will be presented with a username and password, and they are jumping onto this Bastion host. And from there, there'll be connections open to your backend Windows or Linux machines. And on this Bastion host, you will have all the tools that will help you to connect to these virtual machines. So this will help in extra security, because first of all, the data is all encrypted on protocol on port number 443 on HTTPS, which is a hypertext transfer protocol, on a secure manner. And then from here, you will anyway have a respective another security layer here. So that is what Bastion host is being used for now, or sometimes also called as jump box over HTTPS. Now, if I want to show you how it look like on how will you create on cloud or Azure, and if you're part of, I think it's covered in one of the trainings in Azure administration, and could possibly be an Azure solution architect, depending on the exam topic. So there'll be definitely a hands-on lab on Azure administration on how to create a Bastion host and how do you connect it. But let me quickly go and show it to you on portal. So this is your Azure portal. You should all have a account. You simply go on to the Bastion host, and or search for Bastion, Bastion. Yeah, so you click on this Bastions and click on this, and from here you will click on create Bastion. Now there is some additional charge. I think it's what I've heard is a little bit expensive service, but you can check it out. You can't stop. Oh, one thing good point is, as of January or February 2021, you can't stop the Bastion host. You can only terminate it. So you'll be charged for every time Bastion host is running. So like similar to that, you create a resource, or you put this Bastion host on a resource group, you give it a name, you tell in which region you're going to place this Bastion host, and then where do you configure this Bastion host, in which network you're going to configure this. You'll be providing the IP address, whether you want to create a new IP address for this Bastion host, or you want to use an existing IP address, and you can review all the details and create it. So that's Bastion host. In this lesson, we're going to look at NAT Gateway, and we'll also look at Azure DNS. So first, what is NAT Gateway? NAT stands for Network Address Translation. So it basically hides the identity or IP address of the server which it's going to present its client. So to give an example, let's suppose you and me are talking, but I don't want to present myself saying that myself is Atul, and we put one person in the middle, and that person, you talk to that person, and that person in turn talks to me, and then I'll basically respond back, and that person in the middle will forward request to you. So that NATs is basically what it does. It's hiding the identity, network address translation. It's translating the address from client to the server, and when server respond back, it translate it gives the it hides the server's identity or server's network address, and then present to the client as if that NAT server is presenting. That's what this NAT does in simple terms. So NAT simplifies the outbound only internet connectivity for virtual network, meaning when a request goes out from a machine or a subnet running inside a machine, then it will go out when it present to the external world. It will be connecting through the NAT gateway and present the IP address of the NAT instead of the server's IP address. That's what in a simple words happens. So outbound connectivity is possible without any load balancer or public IP directly attached to the virtual machine. So this will also help if you have a virtual machine and there is no public IP, or there's no outbound connectivity, or there's no load balancer for outbound connectivity. NAT will help you in reaching out and will translate the IP address of the client. Now, NAT is fully managed by Azure and highly resilient, which means it automatically will have active. You don't need to worry about having high availability for NAT. So now with that NAT, you get a public IP, and you can also set a public IP prefix, which means a number of IP addresses, which means you put a CIDR address, and I'll explain you what I mean by CIDR address here, or explain you what its prefix means. So not only you can use one IP, but a set of IPs that you want to present. You can use, or NAT gateway will use any of these IP addresses to present to the client. That's what it will be doing. And how do you attach a NAT gateway? So I've already, let's suppose you've created a NAT gateway. I'll show it to you how to create it. But then you will go to a virtual network. Inside that, you will go to the subnet, and then when you click on that subnet, for the example, in this case, default subnet, inside that there'll be a NAT gateway option. You can select that, and that is how you associate the NAT gateway. So the machines within that subnet will start using that NAT gateway. Let's quickly go and show it to you how to create that NAT gateway. Again, this is a beginner's 101. I'm not going to go in detail, but depending on which training you are part of, whether it's Azure administration, Azure solution architect, we might be going deep into these topics or giving you more hands-on lab. So simple is we'll create a NAT gateway, and this is where you will provide all the basic name of the gateway and in which availability zone you want to place the NAT gateway. Resource group, by now, hopefully you know what is resource group. But this is what I wanted to show you, outbound IP. You can select a IP address of associated with this IP, with this load balancer. And this is where you will be selecting the public IP prefix, which is nothing but a set of IP addresses in a CIDR format. So this is like you see name, and then how many IPs do you want? CIDR 28, which will have 16 IPs, or do you want CIDR 31, which will only have 2 IPs? Or if you want to have 4 IPs, you'll select CIDR 30. That is how you do. So that's our NAT gateway. Now, what is DNS? So DNS, as name suggests, is a domain name server. When you access a website, you use them, or you access them via name, for example, K21Academy or a google.com or something else. Those names usually, but actual servers are listening on a particular IP. So how to translate name to an IP, that is handled by DNS. So DNS will be converting a name to an IP so that client can then reach out to that IP by that name. Instead of behind the scene, they will use that name. So that's what DNS does. It resolves name to an IP address. And these DNS names that you have can be managed within Azure. That's what Azure DNS is. So how do you, also when you're creating a network, Azure comes with its own default DNS server, or you can have an external DNS zone management, or you can say, hey, I want to externalize, or I want to use a custom DNS server. So you might have, like, let's suppose you have Microsoft Active Directory or some other DNS management solution. So instead of using Azure DNS for name resolution, you want to use custom, you can go and change that as well. So you'll be changing it to, you'll be going to Azure Virtual Network, and then inside that you'll be saying DNS server, and then you say, I'm going to use default DNS, or I want to use custom, which probably could be external source like GoDaddy or something. And then you can also manage your DNS. So that's DNS. Lesson we are going to look at load balancers. Now, as name suggests, a load balancer balances the load. It takes a request from the client and then forward it to the backend servers on which your application is running. So there might be a bunch of virtual machines on which you might be running a web server or an application server. So load balancer will forward those requests coming from the client to the backend server, and then as the response comes back from the backend server, forward that response back to the client. Now, there are few load balancing rules, which means it could be round robin, meaning first request to this VM, second request comes from another client or maybe same client to the second machine and third machine, and so on. So that's a round robin. Or maybe weightage wise, you can say like 40 or 50% to the first VM, and then remaining 25% to the second VM, and remaining 25% to the third VM. Like that you can do. So there are multiple load balancing rules you can write. Or you can say server affinity or client affinity, which means if a request comes from the client, always forward first time, whatever server it goes to for the next 3 hours or 4 hours or 8 hours, always send to this same client, unless maybe client deletes a cookie or something like that. And then there are health probes, basically to constantly monitor that these backend VMs are up or not, and if our application is running and the listener on or a web server or application server listening on these servers are actually responding or not. And then depending on whether if they're not listening, then take them out from the load balancing backend servers or not to forward these requests. That's load balancer. Now, load balancers are of two types: public load balancer, or we call external load balancers, and also the internal load balancer or private load balancer. We'll explain you that as well. So you have a users which are exposed to the public or internet that we call public load balancer. So they will have a public IP, and they probably will be listening on a port number, and a load balancer can also listen on multiple multiple listeners. So in this case, it's listening on a port number 80 and then forwarding requests to the backend servers on port number 80. It can also listen on multiple port numbers like 80 and 443 and then forward it to either one single port number 80, or it can forward it to multiple port numbers like 80 and 443 or whatever. So you can configure these. These are all configurable options. So this is load balancer public. Similarly, private load balancer or internal load balancer will be for requests, or in that case that load balancer can only reach from within a Azure network. So that is basically useful for your backend services. So let's suppose in this case user comes, they forward it to the public load balancer, which goes to a virtual machine where you have your applications running or application server, and that application server then in turn forward request to the database, but the database is through this, for example, this SQL database through the another load balancer, which is internal load balancer on port number 1443. So that's load balancer. This is an example of full diagram. You have internet requests coming from public load balancer, and from that you have web servers running on that VM, and that in turn will be forwarding requests to the backend load balancer and then forward requests to the internal load balancers. Oh, sorry, this is the internal load balancer forwarding requests to the internal database servers, for example. So these Azure load balancers work on both layer 7 of OSI model. So this is what you see is about OSI model of networking. If you Google, you will understand that, or if you want to go a little bit deep into these networking concepts. So there are 7 layers. So this Azure load balancer works on layer 7, which is application layer for HTTP and HTTPS, or these. It can also work on layer 4, which is TCP protocol. So layer 4 and layer 7. Now there is another load balancer which we call application gateway, which works on layer 7. So which we'll talk about in next lesson. Now, if you want to go and create the load balancers, you can go to the Azure portal and create. I'll show it in a minute. So these are load balancers, both TCP and HTTP or HTTPS layer 7. We're going to look at application gateway. So which is something similar to the load balancer that we saw earlier, but it's on layer 7 of OSI model, which is at the application level, which is for HTTP or HTTPS level. So as I said, what it's going to do is you have a browser which will have an app gateway or will hit the request to the app gateway. And that app gateway will have, or this the app gateway will have a HTTPS listener, which will then forward request to the backend pools, which could be a virtual machine, which could be a web app or different applications. They're listening for web request. Now, there might be some HTTP rules that you can set on this application load gateway. So the one difference between load balancer and application gateways, load balancer can listen for both layer 4, which is your TCP level, TCP IP level, or an HTTP HTTPS level, whereas application gateway is specific to the HTTPS level. The advantage in application gateway is that you can use the HTTP rule, like you can have path-based routing in this. So application gateway support, and you can say if a URL is, for example, this URL, then you can say if it's /images, forward it to this pool of servers. If URL is /video, forward it to this pool of services. These are all done in application gateway, and these are done at a layer 7 load balancer. You can also configure a multi-site routing, where you can have multiple sites, website 1 and website 2, or URL 1 and URL 2, fronted by the same application gateway, and say if it's website 1, forward it to these pool of servers. For URL 2, forward it to this application gateway. So that's application gateway. Let me quickly show it to you on Azure. How do you create one? So this is my Azure portal. You will search for application gateway. Application and application gateways, click on this. And this is where we will say click application gateway. And then you specify same as your subscription, or which subscription you want, under which you define the resource gateway, name of the application gateway, and then other parameters of the application gateway. And then you will see what will be the front end address you will be needing. We'll provide all these details. So then you'll say front end, what is the URLs you want to expose, then the backends, this is where the UR backend servers, and then configuration, like if you want host-based routing or other rules that you do, and then you create application gateway. We are going to look at Azure Traffic Manager. So this is another networking service which is used to route or to determine what is the best possible endpoint to route the client request. So as shown here, let's suppose you are a user and then you want to access a website. So you are going to use that URL to DNS that we saw earlier. The DNS will give you the IP address. So instead of giving that IP address or the load balancer or the server, it will be pointing to the traffic manager, or we are going to give this URL pointing to traffic manager to the user. The traffic manager will then see the client request, and based on the rules that you define for the traffic manager, it will find out the best route or best route for user to access, the quickest way to access the URLs. That is what this traffic manager is used for. So user will then take that endpoint and will access that application. So this traffic manager is used or more effective when you have disaster recovery solution, or when you want very highly available, best possible solution for your customer. So to give an example, you can have a traffic manager, and that traffic manager may be, and then you have two sites. So for example, one site is in Europe, and second in US, and maybe third site in Australia or Singapore or Asia, something like that. Now, on top of that, there'll be a traffic manager. Traffic manager will forward request to, and there are multiple load balancers. One is in US, another in Europe, another one is in Australia or Asia. And then according to those load balancers will have their backend servers. Now, traffic manager will determine based on the rules you define and say, hey, this person is coming from US, let them route that traffic to the US servers. The traffic manager will do. Or if the person is coming from Europe, then route traffic to the Europe. That's one use. Traffic manager can also be used for failover. So if let's suppose one site is not available, one region is not available, the traffic manager will say, hey, this backend service is not available. Let me forward that request to so and so server. So that's what is traffic manager used for. Now you can go into the Azure portal and create a traffic manager, and then routing method. You can, all these are routing methods. You can do a weighted, which means you can say 50% to this place or this site, and the remaining 25% for this. Or you can do based on performance, like which is the better response time, or you can do based on geography. So if your user is coming from this country, forward it to this server, this set of servers. So these are all purpose of traffic manager. We are going to look at one of the two methods to connect your Azure network with on-premise networks. And on-premise, which means, when I say on-premise, I mean customer data center, or the data center which customer already has in their premises, or managed by someone else in someone else's premises, and from which you want to connect to Azure cloud. So there are two ways. One is express route and second is VPN gateway. So here in this lesson, we're going to talk about a very high level express route, and then in the next lesson, we'll talk about the VPN gateway. So both are ways to connect, but express route is a dedicated gateway, or assume this is a dedicated pipe between the customer's network and the Microsoft network. So this is what you see Microsoft Edge when we say. So one end of the Microsoft cloud, which is this here, and another end of the this express route is this here. So customer will be configuring some devices on their side, and then there will be two dedicated pipes for high availability. We also called as express route circuits, and there'll be one primary connection and second is a secondary connection, and then that will come and connect to the Microsoft Edge, which is a, you think of it as an edge, as a service on the edge side, one end of the tunnel, and that end of the tunnel will be talking, or this edge will be directly anyway connected by default with Azure network here, or if you can use the same express route to connect to other Microsoft software as a service, or Microsoft SaaS, like you're peering with Office 365 or other public IPs or other services. So that is all in a nutshell express route. So it's a dedicated pipe. Now, one thing to note here is that, which will all cover here as well, that is very fast, and you always get a dedicated connectivity. So whatever GBs of data, gigabits per second traffic that you between your customer network and the Microsoft Azure network. Now, express route is slightly expensive, or more expensive than VPN gateway. But in VPN gateway, the data is traversed between client and server securely over the internet. So you can't guarantee the bandwidth that you get because you're dependent on wide area network or over the internet. Whereas on this, which is express route, there is a dedicated line or dedicated pipe, and you always know that at least you're going to get that much bandwidth or network traffic, a network bandwidth that you agreed with your customer. So what is here on left hand side, there's something called as gateway, which we'll talk about. This gateway, which is at a customer premises, is also called as, we represented in Azure as a local gateway, local network gateway, which we'll talk later. But this is a gateway on customer side, and customer will have some devices that they need to put in their data center, which is going to talk to the other end of the express, or one end of the express route circuit. The other end of that express route service is already connected with Microsoft Edge, and that Microsoft Edge will be connecting to, you're going to create a gateway, which is another gateway, which is express route gateway, and that express route gateway will be connecting to, or connected to your this virtual network. So this is in a nutshell on a high level about express route. We are going to look at VPN gateway, or virtual private network. VPN stands for virtual private network gateway. How do you configure? And there are two types of gateways, S2S and P2S. We are going to cover both site to site and point to site, and what are these configurations are. And also very high level overview about what all things are required in order to implement S2S. So just to do, as I said in one of the previous lessons, I said express route is to connect your Azure cloud network with the on-premise network or customer data center through a dedicated pipe. Whereas, as the name suggests, The virtual private network VPN gateway is also a connectivity, but that connectivity is over your internet on IPsec VPN tunnel. So there's a IPsec, and this IKE is the key encryption or encryption key. And you can Google these things. These are all standard VPN keys. There's nothing specific to Azure. These are standard IPsec or Internet Protocol Security IKE protocol. On there, as I said, there are two ways to connect. One is this one here. We are talking about S2S, stands for site to site. So you have on-premise, and you might have multiple sites of on-premise, or you can have one site of as well. So multiple sites, or assume you only have one site, that will have one end of VPN tunnel. So there'll be a VPN device at customer side, and there's another VPN device which you create with something called as VPN Gateway that you configure on Azure Cloud. And one end of this VPN gateway will be talking to Azure, other end of this VPN gateway will be talking to through this VPN tunnel onto the VPN device that that represents on-premise. So in on-premise, there will be a public IP which will be able to talk to this VPN gateway or this end of the VPN gateway. This is a secure tunnel, but that data is going to move over the internet here. And like that, you can configure multiple. So that's VPN gateway. Now, as I said, the local so then in VPN gateway, there is also called as a local gateway. When you define a VPN gateway, you also define a local network gateway. So this local network gateway is different from virtual network gateway, but that represents this. When you're defining the virtual network or VPN, you also need to represent this end of on-premise device in your when you define the VPN gateway. So the virtual representation of the on-premise device or on-premise VPN device will be called as local network gateway. So local network gateway is a representation of your on-premise network that corresponding VPN device, as I said earlier. So the VPN device, its configuration, virtually on, you need to represent that somehow in not somehow, but by creating this, that representation is called as local network gateway. So, and again, when you define the VPN gateway, you will also be creating a local network gateway. And so here you will be saying name, IP address, and this is actually the public IP of your VPN device in your customer premises. That is what you'll be creating. So you can create it from your Azure portal, or you can also create it from Azure CLI or Azure PowerShell. Then, as I said, VPN gateway are of two types. One is site to site, and second is point to site. And I'll explain these two here by the diagram. So site to site is your entire data center or customer's data center. So this is a customer data center, and this is your Azure server or Azure cloud. Now, in the customer data center, there'll be multiple machines. Your laptop, when you connect your office network, also comes under this. So that's we call site to site. So this is a customer site. This is Azure site to site connection, IPsec VPN. Now, this diagram someone might say radius server. It's for authentication and authorization identity. So you can integrate this on-premise VPN with your radius server for identity management or for login for Active Directory. Again, we are not going here. So that's my site to site. Now you can also configure site to point, or sorry, point to site, and point is your laptop. Point could be my laptop, which will act as another end of this VPN tunnel. So I can install a VPN client like OpenVPN on my server on my laptop, and then configure a VPN tunnel with my Azure VPN. So the data between my laptop, which is acting as a point to my Azure network, will go as a point to site as a secure channel. So that point to site is, or that is called as P2S. So that's why you see point to site, and this is site to site. So just to do a quick recap, site to site VPN connection is usually to connect your on-premise network or customer data center network to a Azure portal over a IPsec �இ𝐾E protocol, whether it's 𝐼KE version 1 or version 2 VPN tunnel. Now, this type of connection requires a VPN device. So there will be a physical VPN device that will be located on your premises, and it will have an externally facing public IP that you'll be using when we said earlier defining a local network gateway. Now, whereas point to site is a VPN gateway, connection lets you secure connection from your virtual network from an individual client computer, which could be my laptop or your laptop. So on that individual client laptop, you're going to install a client like OpenVPN. Now, if you're part of our Azure, if you're listing this in Azure administration AZ-104, there'll be a lab activity guide to perform this. So this is my site-to-site and point-to-site VPN connection. So, and this is site-to-site where this is my Azure network. And here I'm defining my on-premise network. So this is my local gateway, or this is actually a representation of that local gateway, which I'm going to define here. Now, when I'm defining a VPN gateway, I'll be defining them into, I'll be creating something called as gateway subnet. So when you create a subnet, you will be creating a subnet, which will be marked as a gateway subnet. In that, I'm going to define my VPN server. So that's the VPN. Now, there's something called as Azure Stack, which is your entire cloud, but at customer premises, you have the hardware and the cloud software, but at customer premises, that's called as Azure Stack. That also you can integrate with the VPN in the same manner. So it's site-to-site VPN. Now, in order to implement your site-to-site, in on-premise, you'll be installing or configuring a VPN device on your customer data center. Or so your customer data center's network team will define that. You'll be defining a VPN connection. On Azure side, you'll be creating a VNet or subnet that you want to connect with your for your VPN gateway. And then you optionally, if you want, you can define a DNS server on that, but you need to create a gateway subnet. As I said, this subnet is subnet in which you'll be creating a VPN gateway. So that subnet will act as a gateway subnet. So you'll create a VPN gateway. Gateway subnet. Inside that, you will be creating a VPN gateway. And then you will be creating a local network gateway, which will be representing your device, which is on cloud. And that is end-to-end you'll be doing. Again, if you're part of Azure administration, AZ-104, there'll be labs for that on how to implement a point-to-site VPN gateway, as I said. Now, then you have a virtual WAN, which is a wide area network. So when you have multiple virtual networks, okay, and you have multiple sites and branches, so instead of connecting all of these separate branches separately with each of these network on Azure cloud, what you can define is you can define a virtual WAN that will act as a hub. And again, there's another concept of hub and spoke, which I'll cover later, but there's a implementation of virtual WAN that you set up. And that WAN will act as a connectivity, and that will act as a join. And then this VNet can go and talk to this branch, or this VNet can also go and talk to this branch. And this VNet can also go and connect to all those which are connected to this central virtual WAN. So this virtual WAN will act as a interface, and all these networks can talk to all these sites, or these sites can talk to each other, and so on. So that's virtual WAN. We're talking about networking for beginners in Microsoft Azure. My name is Atul from team K21Academy. So let's begin with this. What is VNet Peering? So in Azure, you have different networks, and these networks are specific to regional or region. So when you create a network, it will be available only on that region. You can create multiple networks or VNet inside a region, but if you want to create, or if you have machines on two different regions, then you'll be creating two different networks. Now, machines within network can talk to each other over the private IP, over the internal IP of that net or those machines. But if a machine in one network wants to talk to a machine on another network, either within the same region or across different region, if they want to talk over a private IP, then they should be peered, which means they should be able to talk to each other. And that process is called as peering. Connecting of two networks within same region or across region is called as peering. So if I'm connecting two networks, they are within the same region, that we call it regional peering. If I'm connecting two networks or peering two networks, they are across different regions, we call it global VNet peering or global peering. I hope that makes sense. Now, in order for me to peer two networks, I'll go to the virtual network, VNet, select the network that I want to peer, click on peering inside that network, and then you click on add, and you'll be able to see a another network and you should be able to peer that. Now, there is one more property which is called as gateway transit, which I'll explain you in a minute. But before that, I hope you're clear with VNet peering, which is connecting of two networks. Now, you can have more than two networks as well. So let's assume you have a network 1 and you have a network 2 and you have a network 3. Now, all these three networks wants to talk to the on-premise network. Then you'll be creating a VPN gateway, as we saw in one of the previous VPN module or express route module. You'll be creating a VPN gateway here or a express route gateway here. You will also need to create one gateway here and one gateway here. So 3 gateways connecting to on-premise device with 3 different settings. That's a very time-consuming or a unnecessary exercise. So what you can do is you can configure these 3 networks in peering. So you can have one network, second network, and third network peer to each other. But where this network is a central network we call hub network, and that hub virtual network will be talking to spoke networks, these 2 different networks. So that is called as hub and spoke model, where one network will be connected to other networks, one central network which is talking to other networks. Now, beauty with this hub and spoke model is now I only need to configure my VPN gateway in one here, which is hub model, and which is talking to on-premise. Now, if this on-premise needs to talk to the spoke model, it can do that. The only condition is that it needs to configure a gateway transit. So I'll explain you that as well. So if this on-premise machine here wants to talk to machine here in this network over their internal IPs or private IP, it can do. So this will send a connection to this hub 1, and then hub will then forward it to the spoke, and they will be able to see each other. Now, in order to achieve that, there is a property that you set, which we saw when we are configuring gateway transit. When you're defining, you will say, oh yes, I want gateway transit. So in that scenario, gateway transit will allow, so if I set this gateway transit between these 2 VNet, this VNet hub and then VNet B, then any machine on premise can talk to this VNet B through this gateway transit, because we have allowed the gateway transit. So gateway transit is a property that you set at peering when defining peering that lets one virtual network, this network, to use the VPN gateway that is peered to connect across environment. So that is what we are going to do. So if, let's suppose, this network is using transit, it can use this VPN gateway to go down. If this machine is not, this VNet is not configured with allow gateway transit, then this machine or this network or machine in this network can't use this VPN gateway because gateway transit is not allowed. So that's gateway transit. So in this model, here we have hub, which is connected to 2 spokes or spoke, and they can talk to your on-premise or other networks through hub and spoke model with gateway transit. So I'm peered, but with the gateway transit. So this can talk to these, and this can talk to these as well through this VPN that we've configured because we enabled gateway transit. So that completes this hub VNet peering, which is of 2 type, global VNet peering or regional VNet peering, with a setting called, or a hub and spoke model with a setting called gateway transit.
Well, that was our expert on Azure networks. Now, if you want to learn more and get Microsoft certified, then sign up for the waitlist of the Azure certification of your choice. For Azure Administrator training, please visit K21Academy.com/AZ104-waitlist so you don't miss out on the chance to be part of this in-depth training and get notified when the training starts. And if you are interested in Azure Solution Architect certification, then please visit K21Academy.com/AzureSA-waitlist and join the waitlist to skip ahead of the crowd. Please click on the subscribe button so you don't miss out on our future videos. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.